So there are 5 ways to prove that a quadrilateral is a parallelogram. I'm going to read it to you, I'm going to tell you the shortcut, and I'll show you what that will look like. So if both pairs of opposite sides of a quad are parallel, then the quadrilateral is a parallelogram. All right, shortcut. It's not that short. So it's going to be quad, both pairs, and you need the word both. You do need that word both. Quad, both pairs, opposite sides, parallel, yield, so we do that with an arrow, parallelogram. So that's the first way to prove that a quadrilateral is a parallelogram. So quad, both pairs, opposite sides, parallel, yields parallelogram. All right, what would that look like? It would look like if we had our 4-sided figure, you would need to show that the top is parallel to the bottom, and you'd need to show the left is parallel to the right. You need to show both pairs of opposite sides parallel. One pair of opposite sides parallel is not enough. So that's one way to prove that a quad is a parallelogram. Second way, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So shortcut, quad, both pairs, opposite sides, congruent, yields parallelogram. Okay, so once again, what does that look like? It looks like if you have your 4-sided figure, you need to show the top is congruent to the bottom and the left is congruent to the right. We need to show both pairs of opposite sides congruent. Okay, next one. If one pair, so now it's not both pairs, now it's only one pair. If one pair of opposite sides of a quadrilateral are both parallel and congruent, then the quadrilateral is a parallelogram. Shortcut. Quad. Now we're not going to say both pairs. What are we going to say? One pair, opposite sides, congruent and parallel, yield, so your arrow, parallelogram. Okay, so what does that look like? Looks like if you have your quadrilateral, you would need to show either, we can have the top and the bottom side, that same side that's congruent, you'd also show that it's parallel. Just one pair, but you'd have to show that pair both congruent and parallel. Or it doesn't have to be the top or bottom. It could be the sides. So we can show the left and right side congruent or parallel. But whatever it is, if it's only one pair, you need to show whatever sides that are across from each other, both congruent and parallel. All right, number 4, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Shortcut, quad, diagonals bisect each other, yields parallelogram. Okay, so what would that look like? Remember, diagonals have to be from one vertex to the other, and they're going to be cutting each other into 2 equal parts. So that's how that would look. And the last one. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Shortcut. Quad. Both pairs opposite angles congruent yields parallelogram. So what does that mean? That means we have to show both pairs of opposite angles to be congruent. Then we can say it's a parallelogram. So those are the 5 ways of proving a parallelogram. Would you guys like a little do now quiz on this tomorrow for some extra points? Basically, you just write down the ways to prove the parallelogram, draw what that would look like, and that'd be an easy 10 points for you guys. I'll leave it up to you. Let's take a vote. How many people want to get that do now quiz? Majority? 1, 2. Thursday, I mean. Yeah. 1, 2, 3. Okay, you got that's the majority. It's good. These little do now quizzes are actually good for you because either way you have to memorize it before Friday because your test is Friday. Just makes you memorize it a little bit earlier. Oh, poor you the most. Okay, let's do a proof. Okay, so now. Oh, I'm sorry. This one?
So all we need to know is just we don't need to. We need the.
I'm sorry. Oh, the first diagram. This one? You're welcome.
This one, can you
Yes.
go back to number 3 so I can track that down?
Number 3?
Yeah.
It's there.
He doesn't have his
Maybe
eyes,
if you
so
were
we have
actually
to.
paying attention, looking at the screen window, that would be.
So we just need to do the easy way.
I was typing, I realized I couldn't do that. Okay, I'm good.
So for the do now quiz, you're going to write down the shortcut or the long version, whichever one you like, but then you'll also have to draw what it looks like. Okay, what would that look like? So like all my diagrams on the side, you'd have to draw what that would look like. We okay with what I'm going to expect? Okay. All right, let's do a proof. All right, so it says given ACDF is a parallelogram. So that's the big quadrilateral. Given that the big quadrilateral is a parallelogram, then we have angle AFB, that's this angle over here, is congruent to angle ECD, this angle over here. We want to prove that FBCE is a parallelogram. So we need to prove that this is a parallelogram. There are 5 ways to prove a parallelogram. Let's draw them out. Let's draw them out. All right, the first way to prove a parallelogram is what? Somebody tell me one way to prove a parallelogram.
Quad, both pairs of opposite sides are parallel.
Good. Both pairs of opposite sides are parallel. So we can try to show this. All right, what's another way of proving a parallelogram? Not Sam. Somebody else can read it. Simon.
Opposite sides congruent.
Both pairs of opposite sides can be congruent, so we can try to show this. What's another way of proving a parallelogram? Vincent. Good. Both pairs of opposite angles are congruent, so we can try to show this. What's another way of proving a parallelogram? Michael. Good. One pair of opposite sides both congruent and parallel, so we could do this or this. All right, one more way. What's the last way of proving a quadrilateral is a parallelogram? Maya? Good. The diagonals bisect each other. All right, so for this yellow highlighted figure, we need to show one of these, and then we would be able to say it's a parallelogram. So let's see. We know that the big shape out here that I'm highlighting in green is a parallelogram. So that means we can use any properties of a parallelogram on the big green quad to help us. And we only have angle AFB and angle DCE congruent. So as of right now, are we able to say FBCE is a parallelogram? No. Now, I can say, since FDCA is a parallelogram, can I say that FD is parallel to AC? Well, if FD is parallel to AC, doesn't that mean that FE and BC also have to be parallel? I can, but then at that point, I would also need to either get FD and AC to be congruent, FE and BC to be congruent, or I would also need to show that FB and EC are parallel. There's no way right now to show FB and EC to be parallel, and there's no way to show that FE and BC to be congruent. So when we can't get what we want from the given information, what should we do? Prove triangles congruent. All right, let's go ahead and prove triangles congruent. I think it's pretty clear we're going to have to prove these triangles congruent. We already have an angle. Does anybody see anything else we can say to get these triangles congruent? Simon.
AF is congruent to DC.
You got it.
Because parallelogram yields opposite sides congruent.
Perfect. We can say that AF is congruent to DC, and our reason is going to be parallelogram yields opposite sides congruent. Okay, great. So now we have an angle and a side. Get me another angle. Get me another angle. Adrian.
Angle A and angle D.
Good. Why, Adrian?
Because the opposite angles are congruent.
Good. So parallelogram yields opposite angles congruent. So now I can go ahead and I can say that triangle AFB is congruent to triangle DCE, and the reason's going to be angle, side, angle. Do you all agree that I can go ahead and I can CP, CTC, FB, and EC? Yeah. That's one pair of opposite sides congruent. Is that enough to have one pair of opposite sides congruent? No. We either need to try to get this pair of opposite sides to also be parallel, or I can try to get FE and BC to be congruent. Do we agree those are our two options right here? All right, there's no way right now to get FB and EC to be parallel, because remember, in order to get parallel lines, you need the Z or you need the F, and there's no transversal connecting those two lines, and we're not drawing ones in. We don't do that. All right, so we're not going to be able to get them parallel, which tells us we need to somehow get FE and BC to be congruent. Any ideas on how we can get FE and BC to be congruent? Livy.
Can you do like division or subtraction?
We can do subtraction. It's going to be some steps before we can do subtraction, but subtraction can bring us there.
So then like AB is congruent to
Good. So we can go ahead and we can say AB is congruent to ED. So I could put that in the same step number 5. AB congruent to DE. That's still not enough for subtraction, right? Because we have the small parts. What would I need in order to use subtraction? What would I need in order to use subtraction? Sam?
Don't you need to have like the same thing twice, or don't you need to?
No, that's division multiplication, the same thing.
Or don't
Bisect,
you need,
trisect.
a reflexive sign?
Doesn't need to be reflexive. No, not necessarily. Kyle?
You need AC to be congruent with
Good. So we need the bigger segments to be congruent, and then we could subtract away the smaller ones, right? Well, can we say for any reason that FD and AC are congruent? Max?
Parallelogram yields opposite sides congruent.
You got it. So what we're going to do is say now that AC is congruent to FD, and our reason is parallelogram yields opposite sides congruent. Could I have stuck that in with step number 2 if I wanted to? Yeah, I could have stuck that in with step number 2 if we wanted to. So now that we have the full FD congruent to the full AC and the little AB congruent to the little DE, now we can subtract those away, and now we can get that FE is congruent to BC subtraction. And now we have both pairs of opposite sides congruent. So now we can say, step number 8, that FBCE is a parallelogram. Who thinks they know without looking how we can word this? Finn.
Quad both pairs opposite sides congruent yields a parallelogram.
You got it. Quad both pairs opposite sides congruent yields parallelogram. Anybody still copying? Okay. All right, let's do another one.
Are you skipping this? Never mind.
No, I was just looking to see how much was left because there's something else we still got to do. That would have been nice for you, right, Oscar?
No.
Yeah. All right, triangle CAR is isosceles with base CR. So let's go through this and make some conclusions here as we're going through our given information. All right, triangle CAR is isosceles with base CR. What does that mean? What can we conclude from that? Libby.
That the base angles and legs are congruent.
So directly first, we can just say the legs are congruent. We can't conclude base angles just yet. So since CR is the base, we can conclude that CA and AR are congruent. So we could go ahead and say CA is congruent to RA, def of isosceles. But now we can take it that next extra step, right? So the definition of isosceles tells us the legs are congruent. But Livy said the base angles are also congruent, which is true. I'm going to call them angles 1 and angle 2. Can we now conclude that angle 1 and angle 2 are congruent? Yeah. So step number 3, I'm going to say angle 1's congruent to angle 2. Now this is not the definition of isosceles. Who remembers the reason for this? Max.
If legs are congruent, base angles are congruent.
You got it. Legs to base angles. All right, let's keep going through the given. Now they're saying that AC is congruent to BK. Since BK is congruent to AC, I'm going to put the same marking on BK that's already on AC. But now there's another conclusion we can make. Because if AC is congruent to AR, but AC is also congruent to BK, what can we conclude? AC is congruent to AR, but AC is also congruent to BK. Michael? You got it. We can conclude right here that AR is congruent to BK. Who thinks they remember? It's one word. Who thinks they remember the reason for this? Sam? Excellent. Transitive. All right, let's keep going. Now they're saying angle C is congruent to angle K. Well, I'm going to put the same marking on angle K that I have on angle C. So I'm going to put that. But now the fact that I had to use the same marking again should tell me something. So now we have angle 1 is congruent to angle 2, but angle 1's also congruent. Let's call angle K angle 3 to be consistent. So 1's congruent to 2, but 1's also congruent to 3. What can we conclude there? If 1's congruent to 2, but 1's also congruent to 3. Only 2 people think they know? That's it? We just talked about something similar. Vincent?
Angle 2 is congruent to angle 3.
Excellent. Angle 2 is congruent to angle 3. Why?
Transitive.
Transitive. Could I put that in the same step as number 4? Yeah. So I'm going to say angle 2 is congruent to angle 3, also in step 4. Of course. It's absolutely fine if you wanted to make it into another step. Livy?
How do you know if how do you tell it's like not substitution?
Because your statement, so this side, on the left side, what we're writing is saying there's the congruent symbol. In substitution, it will never have the congruent symbol. All right. Did we go through all of our given? Yeah, we went through our given, and we actually made a lot of conclusions, right? As we were going through the given, we were able to make a lot of conclusions. Let's see what we want to prove now. We want to prove that BARK is a parallelogram. Well, there's 5 ways of proving a parallelogram, right? But what stands out to me is that I already have that AR and BK are congruent. Do you all recognize that? Do we see that? All right, so then I'm going to just focus on the ones that have congruent sides. So if we have this, we could either get the same side parallel, or we can get both pairs of opposite sides congruent. Do you agree? Those are the 2 that deals with the opposite sides. All right. There is absolutely no way right now I can get AB and RK congruent. There is no way to get them congruent at all. Can't do it. All right. So this way is out. There's no way to get both pairs of opposite sides congruent. So this way is out. So now that leaves me with getting the same sides that are congruent. I need to get them to be parallel. How do we get sides to be parallel? We need Z's or F's or something, right? So using the 2 sides AR and BK, I can't make a Z because there's no diagonal, and we don't want to draw in our own diagonals. All right, the only time we draw in anything is if there's no triangles, okay? But we don't need triangles for this. So what can I do? I can't make a Z, but what can I make? An F, right? If I highlight this segment down here, do you all see that F lying on its back? And for the arms of the F to be parallel, the armpits have to be congruent. Well, are the armpits congruent? Yeah, so I can go ahead now and I can say AR is parallel to BK. Who remembers how to write this? Yeah?
with C.
Yeah.
Corresponding.
Yeah. Core angles.
Congruent yields parallel.
You got it. Okay, so now what have we just shown? We've shown one pair of opposite sides to be both congruent and parallel. So now we can say BARK is a parallelogram. Without looking back, who thinks they know the wording for this? Without looking back. Livy? Quad.
Oh yeah. Quad. Opposite sides.
Is it both or one?
One.
Good. One pair.
One pair opposite sides. Congruent and parallel yields parallelogram.
You got it. We're going to skip number 3. We're going to skip number 4. Let's do number 5. Let's do it together. Are we ready? Okay, so I'm telling you circle O. Remember, way back when, anytime I tell you circle in the given information, what do I want you to tell me? Radii of a circle are congruent. Exactly. So looking here, you tell me, we're making conclusions right now. Which segments can I say are congruent? Livy? You got it. So here we have SO is congruent to OR, which is congruent to MO, which is congruent to PO. And this is radii of a circle are congruent. Now we want to prove that SMPR is a parallelogram. Well, actually, guys, this is a parallelogram. Nope. Even what did I say when all 4 segments in the diagonals are congruent? What does that have to be? A rectangle. So this is actually a rectangle. Are we proving it to be a rectangle? No, we're never going to prove it to be a rectangle. We're proving it to be a parallelogram. But what is a rectangle? Always, sometimes, or never a parallelogram? Always. A rectangle is always a parallelogram. So is this okay?
Yes.
Yeah. So I'm not concerned about proving it to be a rectangle. I'm concerned about proving it to be a parallelogram. And what have we seen here? How can I prove this to be a parallelogram? The diagonals have done what to each other? They bisected each other. So I'm going to take that extra step and I'm going to write that down. I'm going to say that SP bisects MR and MR bisects SP, def of bisect. And now that we showed that the diagonals bisected each other, can we now say it's a parallelogram? Yes, SMPR is a parallelogram. Right, without looking back, who thinks they know the reason for this? Only 2 people? Come on. Y'all can figure this out. Simon?
Quad diagonals bisect each other yields parallelogram.
You got it. Quad diagonals bisect each other yields parallelogram. Okay, so your homework, no, we're not done. I'm going to have a whole nother thing to show you right now. All right, so for your homework, I'm taking off number 17. Right? Don't forget to study for the Do Now quiz. Remember, you write down the 5 ways to prove a parallelogram and what that would look like. All right. So, scroll down. We have something called sufficient condition. This will be the hardest thing for you, I think, the sufficient condition. Because what's going to happen is on the test, I'm going to draw everything looking the same. So like I'm not going to draw a kite looking like a kite. I'll draw everything looking like a parallelogram or everything looking like a square. And it's really going to be based on the markings that we are able to decide what it is. And now how are we going to decide what it is? I'll tell you, you guys want to add a page. You want to add a page to your Cami notes because you're going to want to write this down to help you. If you see it? All right, so you're going to ask yourselves a series of questions when you're looking at the marked up diagrams. The first question you're going to ask yourself, is it a parallelogram? And how will you know if it's a parallelogram? It has to have one of the 5 things, right? Opposite sides congruent, so I'll draw those. Is it a parallelogram? How would we know? It would have to have one of these.
It only needs one.
One of the figures, yeah. One of the 5 ways. Right? Those are the 5 ways of proving a parallelogram. So you would need to show one. We would need to be able to see one of these 5 ways, okay? So our options, if it's a parallelogram, we can have a yes or we can have a no. All right, let's go to the yes. If it's a yes, then you're going to ask yourself, is there an extra special feature to make it a rectangle or a rhombus? If your answer is no, then it is just a parallelogram. If it has a feature, of just a rectangle, then it is only a rectangle. If it has a feature of just a rhombus, it is only a rhombus. But what if it has both? If it has a feature of both rectangle and rhombus, what does that make it? It will be a square. All right, here, I'll let you write that all down. Too small? Should I zoom in a little bit more, or you could all read it? Okay, what if it's not a parallelogram? Anybody still copying? Raise your hands. Okay. Are we ready? Anybody still copying? Okay, so that's all if it is. So you first ask yourself, is it a parallelogram? That's always your first question. If it's a yes, all right, then you go through these series of questions. Can it be a rectangle? Can it be a rhombus? If it's both, then it could be a square. All right, let's say it's not a parallelogram. Then you're going to look for a kite or a trapezoid. And if it's a trapezoid, then we're going to look to see, is it an isosceles trapezoid? All right, are we ready to see how this works now? Anybody still copying? Okay. Now, it could be nothing. It could be nothing. If it's nothing, we just write that it's a quadrilateral, QUAD. We just say, this is just a four-sided figure. It's nothing special that we've been studying. All right. So the most important thing here is that when we're using sufficient condition, you always start off with parallelogram. That's the first thing you're looking for. So the first question, no matter what, that you're always asking yourself, is this a parallelogram? So, number one, is it a parallelogram? Well, we have one pair of opposite sides congruent, right? Is that good? I'm sorry, opposite angles. We have one pair of opposite angles congruent. Is that good enough? No, we need both pairs of opposite angles congruent. There's no way to get that here, right? There's nothing else leading us to be able to say that the other pair of opposite angles are congruent. So this is definitely not a parallelogram. All right, go back to our chart here. It is not a parallelogram, so our answer is no. So that's bringing us to this side. Since it's not a parallelogram, it cannot be a rectangle or a rhombus or a square since it's not a parallelogram. So our only options are kite and an isosceles trapezoid or isosceles trapezoid. Those are our only options now since it's not a parallelogram. All right. Well, usually in a kite, this is what you'll have to see is that like these two sides are congruent and these two sides are congruent. Do we have that? No. Since that's not the case, it's not a kite. And for any kind of trapezoid, don't we need exactly one pair of sides parallel? Since we don't have that, is it a trapezoid? No. And if it's not a trapezoid, is there any way it can be an isosceles trapezoid? No way. So this is nothing. This is just a quadrilateral, just a quad. Okay, let's look at number 2. Is this a parallelogram? How many people say yes, it is a parallelogram? How many people say no, it is not a parallelogram? Excellent. This is absolutely not a parallelogram because right now it has one pair of opposite sides congruent, but a different pair of opposite sides parallel. In order for it to be a parallelogram, the same sides that are congruent would have to be parallel. So when we ask ourselves, is it a parallelogram, we're going to the no column. Remember, what did I tell you for a kite? We would need top sides, bottom sides congruent for a kite. So is it a kite? No. All right, trapezoid. What do we need for a trapezoid? We need one pair of sides parallel. Do we have only one pair of sides parallel? Yeah, so this is absolutely a trapezoid. But why is it better than a trapezoid? Because the sides that are not parallel are what? Congruent. What does that mean? It's a trapezoid with two congruent sides, which makes it an isosceles trapezoid. Do you see the series of questions we have to go through? All right, next one. First question for you. Is this a parallelogram? Yes, this is absolutely a parallelogram. It's one pair of opposite sides congruent and parallel. Is there any extra special feature here that would make it better than a parallelogram? There's nothing extra special here. So this is just a parallelogram. All right, number 4, what do you all think? It is a parallelogram. There's nothing extra special about it, right? Nothing extra special about it. So it is just a parallelogram, both pairs of opposite angles congruent. All right, number 5, first question for you. Is this a parallelogram?
Yes.
Yes, why? Why, Simon?
One pair of sides are parallel and congruent.
Good. One pair of opposite sides are both parallel and congruent. Absolutely, it's a parallelogram. Then we're going to ask ourselves, is there any extra special feature? There is. They've marked another side congruent, right? In a parallelogram, would it ever have all 3 sides congruent? No, in a parallelogram, the top sides are congruent and the left and right sides are congruent. So this is an extra special feature. It's a very slight extra special feature, but it makes a huge difference. So now our only options here, so we said yes, right? So it is a parallelogram. So now our next question is not, you can never now jump to a square. That's never right. So now you're asking, okay, could it be a rectangle or could it be a rhombus? All right, so go back to the markings. Could it be a rectangle or a rhombus? Well, in a rectangle, are 3 sides ever congruent? No. In a rhombus, are they?
Yes.
Yes. So what is this? A rhombus. This is a rhombus. It's like so many questions that you have to ask yourself, and if you try to jump through them too quickly, you'll probably get it wrong.
So for it to be a square, it would have to like have the right angle or something.
It would have to have something part that's from a rectangle. You'll see, we'll get there as well. Okay, do not jump. Do not jump. Ask yourselves the series of questions in the right order. What's the first thing you should ask yourself? Sam. Is it a parallelogram? Don't get scared. Don't let me confuse you by how I draw it. Is it a parallelogram? Just yes or no?
Yes.
Yes. Why?
The bisecting diagonal.
The diagonals bisect each other, right? Isn't that a parallelogram? Okay, so now you're going to ask yourself, so now we're under the parallelogram column. Yes, it is a parallelogram. Is there an extra special feature that a parallelogram does not normally have? Yeah, what is that?
The right angle.
The right angles in the middle. So you have to ask yourself, okay, the right angles in the middle, is that a rectangle or is that a rhombus? That's a rhombus. Is there anything additional here beyond that? No. So could it ever be a square at this point? No. So what is it? A rhombus.
For a square, are all the diagonals
But that's a rectangle, right? First. So, number 7. First question for you, is it a parallelogram? Yes. Why? Because the diagonals bisect each other, but because all 4 parts are congruent, that makes it better than a parallelogram. It makes it a rectangle. So now we know for certain it's a rectangle. Is there anything extra here beyond a rectangle?
Yes.
Oscar?
Right angles in the center.
The right angles in the center. Who has the right angles in the center? Simon.
Rhombus.
A rhombus. So now it's a rectangle and a rhombus, which makes it a square. All right. Number 8. Number 8. First thing you always ask yourself is what?
Is it a parallelogram?
Is it a parallelogram? You tell me yes or no. Yes. Is there anything special, extra special here? Yes. Oops. Didn't mean to scribble that out. The diagonals do what to the angles? Bisect the angles. Which figure does that? A rhombus. This is a rhombus. All right, you all do 9 and 10 and then hold it up for me. You all do 9 and 10 and hold it up for me.
Yeah.
Oh, 10's sneaky. I don't know if you'll be able to figure out 10, but try your best.
I definitely figured it out.
Definitely can.
I think it's definitely correct. Like,
Actually, before the bell rings, let's just look at number 10. Is this a parallelogram?
Yes.
No. There's only 5 ways to prove a parallelogram, right? There's 5 ways. Does it show any of the 5 ways? This is not a parallelogram, which means it's not a rectangle, rhombus, or square. Guys, this is a kite. Why? Because you can get the triangles congruent, and then CPCTC the top 2 sides. Then you could get the bottom triangles congruent and CPCTC the bottom 2 sides. All right, what is number 9? No. Parallelogram. All right, part of your homework, do you guys see numbers 11 through 20? Is to also do 11 through 20. This homework is so important, I'm going to count it as a double homework. So it will count as a double homework and I will be checking it. Okay, 6 points.
oh my god.
There you go, look at that. Okay.